Hello, this is Annie from Collégiale International Saint-Anne, and me and Charles Langlois, we are going to show you our project Fractal. A fractal is a never-ending pattern that repeats itself at different scales called self-similarity. Imaginary number are any real number times the square root of -1. Complex number is a combination of real number and an imaginary number. It can be written as a plus by I, where I is the imaginary unit and a and b are real numbers. For example, if we find the standard form for a plus by I of this complex number, will equals -3 plus 4i, where the real part is -3 and the imaginary part is 4. We can also visualize this in two dimensions in a plane Cartesian set as complex plane. The real number are in the horizontal axis and the imaginary number are in the vertical axis. Complex number are applications such as solving different equations with function of complex root representing the position of an object in two-dimensional plane, and for designing iPhone. The Mandelbrot and Julia Cette are based on the idea of choosing two complex numbers, z0 and c, and then repeatedly evaluating z n plus 1 equals z n to the 2 plus c. They use the same formula but apply it in different ways. This fractal can usually only be displayed approximately because it is not always possible to tell how a particular point will behave. The color depends on how quickly they diverge to R max. The Mandelbrot process is a plot of what happens when we take the simple equation z to the 2 plus c, but complex number, and feed the result back into z time and time again. The series z n plus 1 equals z to the n plus 2 plus c, where z0 equals c, which allows the value c to vary. Let's imagine that complex number plane is a soccer field and there is a soccer competition. The only difference is players start at different spots. We are judging how many goals they can make before failing. Depending on the number of goals they make, they represent a specific color. By adding more smaller value, a pattern emerges. Thus, they represent the Mandelbrot fractal. Julia Cette is generated by initialing a complex number z by repeatedly update using the series z n plus 1 equals z n to the 2 plus c, where c is a complex concept which allows the value z0 to vary. Julia Cette is the boundary between point 10 to the infinity and those that doesn't. The color change also based to the speed. Julia Cette has visual theme similar to a corresponding area of the Mandelbrot set. In fact, Mandelbrot set corresponding to a complex number or a c value. Then we can take any point in the Mandelbrot set and use it to generate a Julia Cette. By adding gradually changing the c value, Julia Cette shifts the shape only a slight difference from one another, which this makes the Julia Cette appear the same everywhere.
So the formula we input was z squared minus z plus c, which looked like this, and a bit more zoomed in looks like this. So we had to pick a point inside the Mandelbrot fractal, which was 0.14 space 0.0081. So then to generate the Julia's fractal, instead of having the c, we did plus 0.14 plus 0.00i, which gave us this result. And we did the same thing for the second point, which was outside this time of the fractal. And this is the result that we had.
If we want to calculate iteration for the first complex number, we will see that it converges and it respects the expected behavior. However, when we calculate the iteration for the second complex number, we see that it converges also and it's supposed to diverge. We can see how the modification of the Mandelbrot fractal look like. Even if our fractal looks like similar to the original Mandelbrot fractal, we can see a slight difference. We choose one point inside and one point outside the Mandelbrot set, and we wanted the first one to convert. And because we have only real number, the application of complex number was not used. Furthermore, the second point we wanted to be outside the Mandelbrot converge, and it's supposed to diverge, so this means that this point was taken inside the Mandelbrot set. What we can conclude to this project is that a simple equation can form a real complex form, and this is very interesting. Furthermore, can we apply the theory of color like others said to this fractal, or can we say that all around our life is related to mathematics?